everyone, and welcome to my session. Good morning, good afternoon, good evening, maybe. For me, it's still morning. I'm on the west coast of the United States, and I wanted to provide you my perspective about data pipelines. In the keynote session this morning, we heard from some of the guest speakers, and one of the guest speakers was quite excited about the data pipelines. But in my point of view, as much as we're excited about building data pipelines, I think that as an organization, you don't want to build data pipelines and you don't want to maintain them. They should just work. It's almost like think about the plumbing when you don't want to be the plumber. You just want the plumbing to work. Why do you integrate data? Why do you move data? Of course, we do this because we have objectives in mind with the data, and we understand that if we have siloed data, then we can't utilize it, and we understand that we need to consolidate and standardize the data, and maybe we put it in a format that makes it easier to access, makes it more performant to access, but fundamentally, we don't wake up with the desire to move the data. We move the data because we have to, and we'd like to then leave it up to the experts to make sure that, again, call it the plumbing, that the data plumbing works. So who am I? My name is Mark Vanderwiel. I'm field CTO at Fivetran. As came up in the panel discussion earlier today, I joined Fivetran as part of the HVR acquisition. Fivetran acquired HVR in 2021, October. HVR was focused on database replication. Fivetran initially began with SaaS application. And then from my professional background perspective, I have a long experience in analytics, data warehousing, and also data integration at a variety of companies, and worked in the data replication space before as well at Golden Gate, and then subsequent to that when we got acquired at Oracle for a short while as well. So if we look at the ingredients to analytics and machine learning and artificial intelligence, there's really, I look at 4 different ingredients, right? So there's, first of all, the storage. Storage has to be scalable, has to be secure, right? Like, and if we think about the evolution in the last decade or so, we've seen unlimited or sheer unlimited storage become available in the cloud. Then there is compute. We have to be able to perform calculations with our data. We have to be able to utilize it. The computation side has to be powerful, has to be scalable. And again, we've seen platforms come and go. In fact, even if you think 2 decades back, there were data warehouse appliances that kind of took the powerful, the scalability aspect, the computational aspect to the next level. But then in the cloud, we've seen this evolve as well. Data, of course, is an incredibly important ingredient. And if you think about your organization, that's arguably where you have your ultimate differentiation, where the data that you have about your organization is specific to your organization, but it's often siloed. It sits in different applications. It sits in different systems. It is proprietary from the point of view that the data may not always be the same. Let's say you have a product table in one system and you have a product table in the other system. It's not necessarily that the product identifiers align. So how do you deal with this, right? So data is the third ingredient to analytics and machine learning and AI. And the last one, I put them in a single bucket, which is visualization and algorithms. There's algorithms from a forecasting perspective that are arguably analytical, but then of course machine learning, AI is absolutely an algorithm. And then there is the BI side of it. In all cases, visualization and algorithms are based on data. So data is your data. Of course, you might be sourcing from public data sets as well. And then if we consider like, okay, what's the evolution been in the last decade? This is what we see, right? Like there's a lot of cloud in their storage, compute, all of it available as a service in the cloud now, using a pay-as-you-go scheme, right? If I think back through my career, in the early days, people would have to invest a lot of money. They'd make a capital investment. They had to find something that's going to last for at least 5 years, which was the amount of time it would take to write it off. Nowadays, you can get started and you don't pay anything until you start using it. And you have the comfort that you can stop using it anytime and stop paying at that point. Same goes on the algorithm side, right? Like in the visualization side, there's a lot of cloud-based solutions out there that are available at scale, using a pay-as-you-go scheme, which really then focuses your attention on your data. And that's what I'm going to talk about, is your data. So what I'd like to talk about, first of all, is, and I like this quote, data is like garbage. You better know what you're going to do with it before you collect it. And I think that is still so true. Now, Mark Twain was a comedian, and he was a comedian in the early 20th century, so it's been a while. But essentially, this is still so true today. So now let's pull up some statistics on data pipelines, because I think it's important to realize and recognize where, as of 2021, when this research was performed, what the state of data integration was like, or data pipelines, I should say. And a shocking 98% of the companies that responded to this research indicate that data pipelines break frequently. So if you take the flip side of this, only 2% claim that their pipelines work all the time. And you wonder whether they're right if you look at the other 98%. 68% of the data engineers indicate that they have not enough time to maximize the value from existing data. So they'd like to do more with data, but they really don't feel that they have the time to do so. 44% of companies responded indicating that they believe they have key data that is not usable to make decisions. So the data might have been integrated, might have been provided, but still it's not in a usable format to make decisions. And then the last one, which I would argue is almost the most shocking one, is that 59% of the companies responded indicating that they've put in a lot of effort to build these pipelines, to maintain them, to keep them up and running, yet when push came to shove, when they needed this data, they had to delay decisions or lost opportunities due to broken pipelines. So I think this is a very challenging and arguably sad point of view on the data pipeline industry. And again, this goes back to 2021 when there was a survey performed. So let's look at some attributes of the data, right? So first of all, let's start with, where is my data? And data can come from a multitude of places, right? So there's databases where databases could be off-the-shelf applications. You may have a generic application, right, for industry, for the healthcare industry, for example. Could be generic, whether it's like an ERP, right? Think SAP, think Oracle Business Suite. Could be human resource applications, etc. Could also be homegrown applications, right? Somebody built a few tables in a database, build a front end on top of it, and you're using that. It's a critical part of your primary business process. Then there's a lot of applications, and we've seen in the cloud that there's a lot of applications that became incredibly popular. SaaS, software as a service, there's an application almost for anything, but there's also still on-prem applications. You may have streams as data feeds that come from external data sources or internal data sources. Some larger organizations standardized on a data pipeline. Think of a Kafka, and you want to feed that into your analytical system or into your machine learning algorithms. There's files, right? It came up in the panel discussion this morning that a lot of data is still passed around using files, whether that is intercompany or intra organizations, log files, data sharing, etc. There's the Internet of Things, right? Internet type data, sensor generated data, where your refrigerator or your coffee maker might be sending some IoT data, or your toothbrush, right? And maybe you want to do something with that data, or you're the provider, the vendor of that technology, and you want to do something with that data. Spatial information, of course, very important. We all walk around with mobile devices these days, and there's a lot of spatial information and location-specific opportunities that are out there. And then lastly, social media, right? Lots of user-generated content, and you hope it's not bot-generated content, but maybe the Chat GPT question this morning kind of falls into that bucket as well, where some of the arguably some of the algorithm generated data could be based upon social media. Okay, so I talk about multitude of sources. Here is the perspective that Martech Map put together, and this is only for the marketing and technology, or the marketing and sales landscape. These are the different applications that are available, and this is a shocking nearly 10,000 different applications, right? And of course, nobody is using all 9,932 of those. However, you can imagine the challenge if you want to look for a solution that supports any and all of the technologies that are out there. So, so the first challenge is like, where is my data and how do I collect it, right? How do I get it to my destination? Then the second challenge that we're dealing with is we have to get our data timely. So what does timely mean, right? And Marissa Mayer, who was the CEO of Yahoo for some time and one of the early employees over at Google back in the day, she indicated that with data collection, the sooner the better is always the best answer. And we agree with that. So now, if you consider the sooner the better, like, how do you deal with that from a technology perspective? And that is, I think fundamentally, you try to go for change data capture whenever you can. Of course, there is always an initial data sync for your analytical solution, but then beyond that, you want to do change data capture, because it simply minimizes the amount of data that you have to deal with. It limits the impact on the system, right? Your primary business should not be affected by, or should not be impacted by, the fact that you want to build machine learning, or that you want to do some analysis on the data. So limiting the impact is incredibly important. And then so if we then focus more on the database side of this, which is the right-hand side column, asynchronous change data capture, log-based change data capture is a term that is commonly used in the industry for getting data out of relational database applications. And again, avoiding the slowdown of the applications. That's what the asynchronous part of it is all about. And then the log-based side of it, maintaining the transaction boundaries, but still making sure that we can capture this data as close to real time as possible. So third aspect, right? Making sense out of data. So we know where the data came from, we got it timely, and now we want to make sense out of it. How are we going to do this? Because as Jay Baer, a marketing and customer experience expert, indicated, we are surrounded by data, but starved for insights. And this might be your professional life as well. Whereas in my case, I get a lot of data, right? Noise, arguably, and I want to get to the insights of that. And for me, it's a daily chore of shifting through my data inputs to kind of figure out what the interesting information is. But when you think about your analytical data solutions, it's a similar challenge, right? We have a lot of data. How do we create insights out of this? So here is a diagram that kind of shows an ideal world of what this might look like. Um, you have the data analyst on the right-hand side who wants to build a report or wants to report on the data, wants to build a data product, right? Something that maybe your organization sells to your customers that makes your solution more valuable, makes it more interesting for your users. But it can also be some internal reporting where your marketing department tries to decide what's the return on investment on our marketing campaign. So they obviously have a need for data, and where does that data come from? Ideally, that is based on a self-serve connector. That's, if we use the marketing example, there is we're doing advertising on Google, we're doing it on Facebook, on TikTok, on Twitter, on all these different platforms, and out of those platforms we get all this information about how many clicks, who were these people, etc., etc., and we feed that into a normalized schema. Now, of course, because we have all these different data feeds, and we throw in the HubSpot and those in the Marketo kind of example, so we know our customers, we have Salesforce data coming in there. Now it needs to get modeled because all these different platforms present kind of similar data in a different format, in a different way. Now, what if, so the modeling side of that is the next step, but what if that model was a standard model? Because, of course, it coming out of these different applications kind of presents the data the same way, whether you work for company ABC or you work for company XYZ. Right, so that model then puts it into a modeled schema, makes it easy to access. It's then consolidated, and then you can do your analysis. And maybe if there's adjustments required, you might fine-tune the model, or you go back and pull more data, pull different data sets, pull additional data. This is the ideal world. So this is how you try to make sense out of your data and feed it into your machine learning or feed it into your reporting environment. Okay, the fourth aspect, right? So we got the data out of our sources, we got the data timely, we made sense out of it. Now we need to know that we can actually trust the data, right? And specifically, if you think about financial reporting, for example, the SEC will require that you know that your data is actually truthful, and they don't care whether you look at replicated data or whether you look at the actual data source. All they care about is that it's trustworthy, that it's governed, etc. So now there's multiple points of view on this and multiple, I'd say, attributes of this challenge. And I'll start with a first challenge: amateurs hack systems, professionals hack people. This came from Bruce Snyder, who is a renowned industry expert on data security. So data security is a key requirement as it relates to our data pipelines, but it goes beyond that, right? So if we dive into security, right? So here are some of what I earlier referred to as table stakes capabilities, right? So from a features perspective, secure authentication, data encryption when data moves on the wire, other capabilities such as data masking, right? When data arrives in the destination, how do you make sure that people don't have access to it? How do you get the security rules into the destination? So those, I put those in the feature bucket. There's the different deployment models, right? If it's cloud managed, maybe there is a third party in the chain of trust, and some organizations are more comfortable with that than others. There is maybe still a controlled, a managed model where you can execute locally, or you might have a completely disconnected model because you're incredibly security sensitive. Like, for example, you work in the defense industry, or you're a financial institution and you believe that some of your data is so proprietary that you're concerned about any security attacks, and running disconnected is, of course, a great way to avoid external access to your data. And then from a technology perspective, you're looking for the 3, 4, 5 letter acronyms from a certification perspective, industry certifications, whether it's SOC 2, whether it's ISO 27001, PII or some of the industry-specific ones like HIPAA for healthcare and various ones in the financial industry, etc. So now, the other aspect of trust is that no data is clean, but most of it is useful, which Dean Abbott said, who is a chief data scientist at Smarter HQ. And this goes to the point of, well, why would data maybe not be accurate, right? First of all, one reason could be because there's latency, right? Stale data. Think back to the slide that I presented about the survey of the data pipeline, right? Going back to 2021, when 98% of the companies indicated that their data pipelines break regularly. Well, if they're broken, maybe they start introducing latency. But if the analyst doesn't realize that they're looking at stale data, they might be looking at inaccurate data or incomplete data just because there is too much latency. Maybe there's configuration issues, right? We modeled the data and maybe we made a mistake and there is an incorrect data mapping, or maybe we're making the wrong assumptions about the data. Maybe we're filtering data based on some data values, and we've made assumptions about what the data looks like, and we never truly validated it, but as a result of that, data is not accurate. And then, of course, there is the broad category of software bugs, where there might be errors with the data synchronization. Maybe the synchronization is incomplete. You think you got all the incremental changes, but you didn't because due to software bugs. Maybe data got corrupted along the way between source and destination. So there's a large category of bugs, but those are all kinds of reasons why data may not be accurate, may not be correct, but you have to be able to trust the data when you start making decisions, when you're running machine learning algorithms and you like the outcomes, you feed them back into your operational environment, and well, what if that data was not accurate? So what are you going to do? So if you consider the data integration needs, what I covered was connectivity, right? Can your data be unlocked? Where does it reside? From a timeliness perspective, like how soon can you get it? Knowing that sooner is always better, right? We heard this morning also in the keynote session that there is a drive toward closer to real time. Is the data useful? Have we standardized it, transformed it? And lastly, is it trustworthy? Is it correct? Is it clean? Did your data move securely? Now, before I end this, I just want to call out one more thing. And that one more thing is about the reliability of the data pipelines, right? And I can't reiterate this enough. 98% of the companies that responded to a survey back in 2021 indicated that their pipelines regularly break. So now then, if you look at the different ingredients, right, to machine learning and analytics, your data often now lives in the cloud, but then from a data integration perspective, there's also cloud-based services out there that can help you integrate this data and automate and manage some of that data integration, those data pipelines. And that goes to the point of the best data pipelines, I believe, are the ones that you never build, that are managed for you, that are maintained for you, that have this high level of reliability, and not because you want to go yell at somebody when they don't work, but simply because the experts who focus on this, they can do this better than you can, and you can provide more value to your organization when you focus on building out the machine learning algorithms, or focus on the visualization and essentially do something that makes your organization more competitive, lowers the risk for your organization, and or improves the efficiency. So that's it. Thank you very much. And let me see if there's any questions or if we could do any interactive Q&A here as well. And I do not currently see any questions in the chat. Let's see if there's any. anything else? So then with that, I wanted to end the session and close it out. So I hope you all have a great rest of your day. And again, thank you very much for attending the session.